Hello everyone, True Zero Emissions here. So I'm looking in the book, The Don Smith Magnetic Resonance Energy Crafting Systematic Index by Richard Friedrich. Rick Friedrich has a YouTube channel and also has a website, and I think the website is r-charge.com, I think, but double check on his website, on his YouTube channel, Rick Friedrich. And then you can find links to his website there. This book was also available on Amazon and also through Rick Friedrich's direct YouTube channel. I'm looking at the Don Smith rotating separator coil system. And let's see what Don says about this one. The drawing is the simplest possible and is therefore incomplete. The basic idea is clearly shown. Don Smith. I think when Don is saying this right here, I think he's referring to this drawing here, which is the rotating, or this part here, I think is a rotating magneto-restrictive metal wheel, but the whole unit as a whole is Don Smith's rotating separator coil. And I'm studying this right now, and I'm interested in seeing if I can get this system to work. Now, I know others have replicated this with great success, and but doing it oneself can be a journey of great discovery. So what I understand or think is happening, what I think is happening here is, see, because it doesn't show us, does it? See those magnets? Those are magnets inside there. Does it even say that? Coil with neodymium magnets. Okay, so the coil's on the outside. And coil just means, I understand that to mean it's just copper wire wound around the magnets. And the magnets are inside of tube, like PVC pipe, because the magnetic field can reach through the pipe, right? It can reach right through it. In fact, I don't think there's any way to completely shield the magnetic force. We can redirect it, but we cannot stop it. I was recently reading that. Now, anything is possible, so maybe there is a way to maybe fold it in upon itself so it appears to not be there anymore. I don't know. I'm looking at this, and I'm noticing how this same wire goes around these magnets, and then the same wire comes across and goes around these magnets. And when I look at this photo, I think of just taking a piece of wood that I have over here, like those pieces of wood right there, and laying the magnets down. I have these magnets here. I don't know how big these are. They might be 1 inch diameter. And I was kind of practicing moving that neutral point, I'll call it the block wall, B-L-O-C-H, for a person's name. And I noticed that if I took these magnets off, that where the meter read as neutral would move. And then if I put these magnets back on, the neutral point between north and south had moved back over here, right? I think what's happening is, because I'm trying to visualize and imagine what's allowing the energy to go into the wires. It seems like, so in this case, right? Okay, so my understanding is, my research and study indicate that these two sets of magnets have to be in facing one another in an attractive way. So that's a north and a south or a south and a north, right? These have to be opposites, so they want to come together. Furthermore, so I was working with my meter the other day that detects north and south, and the battery died in it, and then I tried to recharge the battery. I tried to recharge the little batteries with my negative energy oscillator, and after about 6 minutes, the battery exploded. So I certainly won't do that again with that charger, and those were not rechargeable batteries. I just wanted to try it as a test, though, as an experiment. So if I hold that button down, see, I have this battery powering that right now. It works. If I hold that button down and maybe I'll just show you. That's really the best way. Oh, there's a magnet right there too. That's a big magnet. But this here, these magnets here, I should have gloves on. I do have my glasses on, my safety glasses, which is absolutely necessary. I always put safety glasses on before I touch magnets. So, I don't know if I can do this with one hand. Let's put the magnets here. And then I'll close the door because it's really noisy. And I should tape this battery. I should tape this battery onto the back of that meter. I'm calling this a meter. I'll call it a magnetic meter. So let's see right now where the neutral point is. See, I wish I could turn that sound off. Let me think about this. I don't know where that sound is. Okay, right there is neutral. See that? When I push the button, it's neutral right there. I'm still holding the button down. If I move this way, see that? Now, if I take magnets from one side off, that neutral point, I'm calling it a neutral point. I think its proper name is the block wall, B-L-O-C-H, for a person's name. I think it'll move if I take the magnets off. Let me set the phone down and try that. Right, 1, 2, 3, 4, 5. 1, 2, 3, 4. I'm between magnet 4 and 5. Taking these off. Okay, so before it was neutral between the 4th and the 5th magnet. Let me go to the same spot now. 1, 2, 3, 4, 5. So right there was neutral before. Let's see if it changed. Well, the magnet's acting a little bit differently now. Okay, well that seems like it's the same spot. When I did this test the other day, and plus I'm not using all neodymium magnets, but I don't know that that's necessary either. So here's my thoughts on this. Oops, wrong way. Usually I slide the magnets together, but I was just using one hand to do this. So these magnets are not that strong, but these are very powerful. The neodymiums are very powerful. So here's my thoughts. In this system, the way that I think this works is that when I'm using the meter, when I'm using that meter, and it's not reading north or south, but I'm holding the button down. So let's say it's in the middle, right? And it's not reading north or south. If I separate the magnets from each other, here's the first question I have. How far can I separate those magnets from one another and still get that reading of not a north and not a south, right? How far apart can I go? Now let's say I can go 1 inch apart, and it still reads as a neutral. I'm just calling it a neutral, where it's not giving me a north and it's not giving me a south. I come between those two fields with what Don is calling a rotating magneto-restrictive metal wheel. The way I want to do this test myself is Don has 4 cutouts. That's 4 areas where the magnets, the field between the 2 sets of magnets, right? This is one set and this is one set. The field between the 2 sets of magnets can reach one another, if I say it that way, right? That it's not blocked. But I would like to take 2 of these areas, so leave 2 open, that's open, and cover 2 of these with, there's a couple different materials he mentions, and one of them that he mentioned, I think he mentions 2 that are not very easy to get, or they might be very expensive materials. And then there's a third material that's literally just neodymium magnet dust. Now when I looked on Amazon and looked on the internet, I don't know if I looked on Google, I know I looked on Amazon, and I was looking for a neodymium dust, and I didn't see it. I just saw what appeared to be just this kind of magnet. And I don't know how to know the difference. I mean, I was looking for neodymium magnet dust. I didn't see any. So it could be powder, dust, or just small pieces of it. And I don't know if he clarified that in here. But I was looking for some kind of powder, right, that I could sprinkle a light coating on some kind of material here. So let's say this is in the large unit here. In the larger unit, in this larger unit, which is that same example, it's the same thing, but just larger, right? So this is the same thing, but this is a larger one. So this is the pair. Imagine this being one pair. So even though the wire goes through there, this wire continues over here, the wire for this one continues over here, the wire for this one continues over here, and that's it. That's the end of that. That's one circuit, if I say it that way. In other words, that's all that happens on this board, is this coil of wire goes around this and then comes over here and connects to these, and then the output for that will go to what Don is showing on this other page as capacitors. And then I'm noticing how he wired these. And this is a transformer, and I'm guessing that's to make the voltage usable, right, to bring it into a usable range. When Don wrote about this up here, and I'll read to you what he's saying about these here. Device 9-1, proof of principle. Now when Don says proof of principle, I understand that to mean it may not be the final product, it's just showing the idea. But just, you know, looking at this and then studying everything Don has ever said and written that I could find, right? It seemed that he was indicating that one pair of these, which is a pair right here, that's a pair, right? This and this, was providing 1,000 volts at 50 amps. And that's, if we multiply amps times volts, 1 times 5 is 5, and then we add the zeros, so that's 50,000 watts. Amps times volts equals watts. it's 50,000 watts coming from just this one right here, just one of these. But looking at this, it's hard for me to imagine that just from these few little wires that much energy would come through there. And how much power, this is a question everybody wants to know, how much power does it take to turn the record? There's a record in there, right? And the record has, I think that record has the neodymium dust or powder. It's the powder neodymium magnet sprinkled. So I'm not sure if you would spray the adhesive on the record first. It's a record. Spray the adhesive and then sprinkle the dust on. It has to be even, right? And then when would the cutouts be there? Would the cutouts be before putting the neodymium and the adhesive on? Probably easier to do it that way, right? So cut out the areas that are desired to be cut out. And I don't know if Don ever said that, if he ever said how many holes he made. My thoughts were in the record to cut a hole on top, bottom, and each side, and then have it so the holes line up exactly with these two, and then when it's rotated it lines up exactly with these two. So as that rotates, it's going to block the field between two attracting magnets in pairs of two as it turns, right? So as the field's blocked, and then when the field comes back together, and I'm not sure, let me think about this. When would the pulse, when would you guess that the energy goes into the wires? Would it be when the two fields, when the two magnets become one again? Because what happens, my understanding is, when that record blocks the area, when it blocks that field between the two attracting magnets, and remember, the two attracting magnets, it's absolutely critically essential. It's a necessary necessity. It's a necessary necessity. It's a very important necessary necessity that when the magnets are separated from one another in that gap right there, and this is to be determined, right, by the experimenter, how far can these be pulled apart and still read magnetically as not a north and not a south. I'm just saying it that way because that's what seems to happen with magnets in the middle area, right? So if one side's north and one side's south, okay, then the neutral area would be somewhere in the middle, right? I think that's what's happening. Now, there's different kind of magnets. Some magnets have, like, this side, like literally this side on this page, toward this page, would be north, and that side would be south, right? So that's a different kind of magnet. I think these magnets are the top side is either a north or a south, and the bottom side's a north or a south, but they're opposites, right? So one side's north and one side's south. So if I took any one of these magnets, it would have a north on one side and a south on the other. So by putting them in series, it just stretches that out to be a north here and one south here, right? And I'm saying series because all the souths, so if this is north and then the bottom is south, then the north of the top next magnet is pulling toward the south of the bottom magnet of the next one, and that just repeats and repeats all the way down, right? And these magnets as well, these are, one side is on the top is north and on the bottom is south, and so they also are attracting together. So here's my thoughts. I was thinking, now we could call this getting ahead of myself, but I feel naturally inclined to try multiple experiments at once right now. So instead of just building this one experiment, and that one may be done first, it may be done last, it might be somewhere in the middle, but I was thinking if I could think of all the different ways I can imagine making this experiment, let's say I can think of 4 different ways to conduct this experiment, right? 4 different variations of it. I guess we can call that re-engineering the Don Smith rotating separator coil experiment. Re-engineering, so Don Smith engineered it, and then re-engineering it, I guess, would be maybe modifying or changing something on it, right? Because I don't have this exact system. So what I was thinking was, and I will also try to build this system as well, but I don't know we don't have measurements here. I don't know what size magnets he's using. Are they 2-inch diameter magnets inside of 2-inch diameter pipes, PVC pipes with caps on them? And then he wraps the wire on the outside. I'm thinking also that I can get a little bit bigger of a pipe. For example, these magnets will fit inside this pipe that I bought recently from Home Depot. So this is a pipe right here. See, this is the cap. This is a pipe right here. It's 1.5 inches, as it says there. And I don't know if 1.5 inches is inner diameter or outer diameter. I don't know that. Let's see if it says though. This was at Home Depot. So I don't know if it's the inner or the outer. I could measure it though. Let's see. I have a tape measure right here. Let's see what the tape measure says. That's very interesting, isn't it? Oh yeah, it's inner. So the inner is 1.5 inches, as you can see there. That's the inner diameter ID. So the inner diameter is 1.5 inches. And I was noticing that this magnet, this round magnet here, the neodymium, could fit inside here. See how much room there is? And it appears that there may be enough room to even wrap the wire around the magnet itself, which is not necessary, as Don demonstrate here. He has that PVC pipe magnets on the inside and the wire on the outside. But I was thinking I might be able to wrap the wire directly around the magnets and then slide this inside of there, and it'll still fit. It may still fit, right? If I ran like I don't know if that would be like a 10 gauge or a 12 gauge wire around that. And I also do not know if this is magnet wire. It doesn't look like it's magnet wire. This looks like ordinary, I don't know if you call it braided wire, just regular copper wire, which usually is a mixture of different materials and it has some copper in it usually. But I can try this. What I'll do is I'll try it, and then if it doesn't work at all or it works a little bit, I'll just change things and try to improve the efficiency. This is what we're all trying to do, is we're always trying to improve efficiency, right? How do we improve the efficiency of something? And replicating nature will always be the path to go on that, to maximize efficiency, right? Because nature, as Leonardo da Vinci said many hundreds of years ago, nature always takes the most efficient path to achieve what nature needs. You know, nature always takes the most efficient path. So that was my thought on this tube. This can be cut into small pieces. I bought 2 caps just for now because I was thinking of just making the one pair at first, right? Just one pair. But this is all the magnets I have for the moment, but I could probably order more of these. These were purchased on Amazon. They're just neodymium magnets. But I think any magnets can work. It can probably be, I think neodymium is preferable because they're stronger. And I do, if I recall correctly, that is what Don Smith is using as neodymium magnets. He even says it here. I think he says it in here. Let's see. Well, let's read the whole thing again. Device 9.1, proof of principle. Prototype energy system for Brazil and Saudi Arabia markets. Note, the coils in pairs left and right. Each pair produces 1000 volts at 50 amps with output into separate bus bars in parallel. Dimensions are 14.5 inches high and then 16 inches long and 10 inches wide. So 10 inches wide, those are good measurements. It's good to know. So 10 inches wide tells me that these pipes are not that wide. Because if this whole thing's 10 inches wide, and we have a gap in there, right, of at least a couple, well, let's probably at least an inch, right? If the gap is an inch, which I don't know, I'm just guessing, because he doesn't say. And I also don't know how far those tubes go into that wood. But they may go all the way in, right? They might go all the way through and then stop flush with the wood, right? Because I don't see anything sticking out in there, see? I don't see anything sticking out past the wood. But look how thick that record is. That's because the record has that neodymium dust on it. Neodymium powder dust. Oh, is that a magnet right there? No, that looks like it might be the motor in the middle, in the inside. It's hard to tell, isn't it? That looks, I think what we're seeing right here on each side, that shiny metal, I think that's what holds the record in place. That's what I think that is. And then it looks like a piece of wood that is equal in thickness to these two end pieces. It looks like the same piece. It could be the same thickness, I'm not certain. I also don't know how thick that wood is. I don't know if that's 3/4 of an inch. But if we read those lines, the layers in it, 1, 2, 3, 4, it looks like there's 4. And this one has 1, 2, 3, 4. Looks like that has 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 5 or 6. And then 1, 2, 3, 4, 5. This might have 5. Well, it might be almost as thick as these outer pieces of wood. It might not be as thick, but it's close, right? Look how close that record comes to that wood right there. Look how close that is. Those are very precise tolerances right there. So I think right here, we're looking at the wood inside there, right there. And it looks like the record is actually rubbing on that, doesn't it? Or almost touches it, or touches it. All I can think is, I sure hope this worked. I hope this actually produced power. I think it did, because Don said it did. You know, did he build this just to show us proof of principle? Well, he described it as this machine here produced 50,000 watts each pair. So you can multiply 50,000 times 1, 2, 3, 4, 5, 6, 7, 8. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. So that's a lot of power. 8 times 50,000 watts. But these get hot, and this doesn't have a cooling system. That's probably why that might be why it's called a proof of principle. Because Don said these get really, really hot. The magnets get really, really hot from that switching, right? What's the switching that's taking place? The switching that's taking place is that these each pair of magnets, that field between the magnets is reading as one continuous magnet. And when that field is interrupted, when the field is interrupted with that material, with what Don is calling a magneto-restrictive metal wheel. Magneto-restrictive. That sounds like an insulating material. I actually wonder if I could use copper in there. I do wonder that, if I could use copper. I just purchased some copper tape on Amazon that's meant for, how do I say it? I don't know if we'd call it isolating EMF, isolating it, or shielding it. I think it's a shielding material, but if it can shield EMF, if it can shield it, can it also work well enough to allow this pair of magnets to be two separate magnets, meaning it would switch between. So what would be happening if we were switching between one continuous magnet and two separate magnets, where this becomes a north and a south, right? North-south, and then becoming neutral, and then north-south, and becoming neutral in the middle. So that switching taking place between those two fields, if I call it that, field conditions. I guess I'll just call it field conditions. That's what allows the energy to come into the wires and the energy is coming from, is it coming from the magnets? I think we could say it's coming from the magnets. And then I think the magnets replenish themselves instantly from the environment. They just stay charged, right? Have we noticed how magnets just stay charged? Now I know people can say, well, magnets have a lifespan. They may only last, 20 years, 100 years, several hundred years. And that's okay. I'm okay with that. If the magnets have to be changed after many, many years. If it worked for 1 year, I would be happy. But I think they work longer than a year. I think neodymium magnets hold their strength for quite a long time, many years, as long as they don't overheat. If they overheat, which they can do in this system, then that would damage them. And I'm thinking in terms of how to keep these cool, and I wonder if the cap on the tube could be left open, and then running a tube or a fan there, like putting a fan right there, and then having maybe on the other side where the magnets are touching the cap, on the other side, right on the inside, in here, where the cap is, on that side it could have holes. Maybe it can have some holes for the air to come out, and then blow the air. Well, either blow the air in or pull it this way, so that way the air is coming in through here and out through the back. That's probably the better way to do it. Otherwise, the hot magnet air is going to go onto the record, and that could cause the record to deform, because an actual record is not going to be very strong, and it's not going to be resistant to heat. So that's one idea, is put little fans, high-powered fans on each tube at the end, pulling the air this way, right? And then drill holes on the cap on that side. And the cap can be left on this side too, with holes drilled in it, and then having that fan there. That might be one way of helping to see if it can help keep it cooler. Oh, so this is one design, and then I was thinking, we'll come over here now. Oh, this is other angles. As you can see, he has the wires. Don has the wires going into, so this one here powers that little motor. I don't know if we finished reading this. Let's go ahead and finish reading this. A milliwatt motor, meaning milliwatts, powers it, which is not even a watt, right? It's less than a watt. So it doesn't take a lot of energy to spin that motor. Turns the magnetic shield, which separates the magnet pairs at their Bloch wall separation, providing magnetic fluxing and useful electrical energy. So it's all right there. That's it. It's the magnetic fluxing that we're looking for, right? I just love this design. I love this. I'm so excited about this. I really love this design. I hope that you can make some version or variation of this and make a video of it. Call it the Don Smith rotating separator coil research video, something like that. And I hope that we can just make millions of these experimentally, and share our research with one another just by making videos. The comments can be turned off if you don't want comments turned on. That's what I do, because I'm just very focused on my research right now. I'm very, very focused. And apologies to everyone that I'm not available to discuss these things on the YouTube channel at this time. But I'm still active. I'm still making videos. I mean, look how many people, when they start doing research, they just leave the channel and they don't come back, right? Because they're just doing everything in private. I love to make videos and share, so I won't stop making videos. I'll keep making videos as long as I can, which hopefully will be just millions and millions of videos and billions of videos. Okay, so let's see what else Don is saying here. Question. Okay, so then, yeah, so magnetic flux and useful electrical energy. So the question is, my thoughts are, how can we get the magnets fluxing with the least energy input? That's one idea, right? That's one way to look at it. And one idea that I had was, imagine these magnets are separated from one another, or even leaving them together like they are, right? Leaving them together. What I'm wondering is, can I wrap a coil around one side of these magnets, right? And pulse that those coils with the magnetic field, well, electromagnet, right? A strong one that's pulsing very strong, right? And if I do that, can I get this magnet fluxing? Can I get it to flux, right? Can I make it flux and then have a wire wound around this the way Dawn does? Have it wound around this, picking up that fluxing, right? So can I get that blotch wall to shift? Can I get it moving? Is that enough? These are a couple different questions. One is, can I get the blotch wall moving by having a strong electromagnet on one side, right? That might be wrapping copper wire around this end, and then it could be either end, and then the north side or the south side, right? If one side's north and one side's south, that kind of magnet. It could also be a bar magnet, a long bar magnet. If I can wrap copper wire around one side and make a strong electromagnet on one side, and I'm pulsing that field on and off, on and off, on and off, can that fluxing allow me to move the blotch wall, right? And will that fluxing, the blotch wall moving, because what's the blotch wall doing here? What's happening here? I see it as moving. I see the blotch wall as moving. In my imagination, I'm going to say it that way. In my imagination, when the record with the neodymium dust blocks the magnetic field, when it shields it, right? When it's shielding this pair of magnets, the blotch wall will go to the middle, I think. But so if this is 4 inches of pipe and 4 inches of magnets inside, if it's 4 inches of magnets, then at 2 inches would be the neutral point, right? But when the magnets come together, when the field comes, when there's a hole, when the hole is there, right, where it's not being shielded, when this pair is not being shielded, where the hole in the record is, right, and that comes between this two, the hole is there, then these two magnets become one again, and the blotch wall goes to here. It goes to the space between the two pairs, right? Not to the 2 inches of the 4 inches. It won't be in the middle of this magnet anymore. It'll be over here. It'll move. So the one that was here in the middle, and the one that was in the middle of this set of magnets, this row of magnets, right, will shift, and then we'll have one here. No blotch wall here, no blotch wall here, but it'll be here. And then when the record turns and it's shielding it again, it separates the two magnets, then we have a pulse, boom, and that blotch wall shifts back to the middle of the 4 inches to 2 inches in, approximately. And of this 4 inches, it shifts to 2 inches in, approximately, right? Because one side's north and one side's south. One side's north, one side's south. But when the hole comes through again, when it comes around, and allows that field to communicate, if I say it that way, with this field and this field to communicate together, and up here with my meter, with my polarity, magnetic polarity meter, if I call it that, it reads it as the blotch wall, which is the neutral. If I understand correctly, it's the neutral area. So right here, it won't read north or south. But over here, it'll read probably north, and over here, it'll read south. But in the middle, there won't be a north on one side and a south on the other, right? These two pairs of magnets have to be close enough together that it's not reading two separate magnets when the hole is between there, right? When the hole is open, it should be reading one magnet right here. Blotch wall right there, the 0 area, not a north, not a south, neutral. So it's going to be switching between the two. So how can I was thinking, how can I do that a different way? Is there different ways I can do this, right? So I'm calling this the blotch wall, B-L-O-C-H. That's the person's name. And this is a magnet. So these are two magnets, right? And these magnets are going to be reading as one. Well, hang on. This is a different design here. Let me explain this design. My thoughts on this one were having one long magnet, right? And it could be a lot of little magnets, the neodymiums I just showed you. It can be these. It could even be these right here. It could be these very magnets. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 of these. So I could have those sitting in here, right here. Okay? And then on this end, I could have a ferrous metal, which is iron, that will stick to a magnet. Right? So when it touches a magnet, it becomes what I think is called polarized. And here's my thoughts, though. Wrap a coil around that metal to make it an electromagnet. And if I pulse, and I don't know if I'd be pulsing with AC or DC or both, right? Think of John Searle's Searle effect generator, right? Which creates a force field around it, and it's a faster than light speed drive system just by spinning magnets, right? Just by spinning magnets in a circular direction. So it's spinning magnets, and then it's also spinning them in a circle at the same time, right? But I don't think it has to be perfect, because nature is very flexible in what we do. I think it just has to be tested in different ways. Because John Searle said his first prototype went right through the ceiling, and it was a very crude prototype. It wasn't anything like what we see on the internet with the final Searle effect generators that we see on the internet, people testing and building and things. Those are beautiful, but his first one was what he called very crude and simple, kind of like a real rough draft, and it worked. It went right through the roof when he plugged it into the toaster and put a load on it. It went right through the roof, through the ceiling, through the roof, and it went up into space, and it never came back as far as he knows. What was it powered by? Well, it was powered by all the energy everywhere. There's megawatts of energy in every inch of space. So there's no lacking of energy. And that's where all of our energy comes from. There's conflicting theories on that, but that's my understanding. So, if this is an electromagnet here, okay, and I send a pulse to it to make this a very strong magnet, and let's say I'm guessing right now that I would make it a south so that it attracts to this north, because I don't want it to push this metal away. I don't want it to shoot this thing away from here, because if I have two like poles, it'll repel it. So I'll make sure that this is the opposite polarity of this. So if this is north, I'll make sure this is south. Here's my thoughts, though. If I do that, if this is a south and it's a very strong one, I think the blotch wall would shift this way, depending on how strong this pulse is. So I think this could shift and go here, like that. Boom, 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 boom. Every pulse, I think it would shift, shift, shift. Furthermore, if I make another, do the same thing on this side, on the south side, but now I'm making a north, right? So I have a ferrous metal. It's not a magnet, but a magnet can stick to it, and it can become magnetized, right? I can make an electromagnet out of it. So the same metal on this side, wind it or power it, right? Power it. I'm guessing it would be the opposite polarity, right? So I think that means this would be the plus and this would be the minus. I think that's what that means. Whatever it takes to make this a north on this side, right? Same thing as this. Now, if I can pulse this and then pulse this one afterward, right? Intermittently, pulse, 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 pulse. This blotch wall, or this neutral area, would shift this way when this pulsed, and it would shift this way when this pulsed. This is all theory. This is theoretical, right? I'm a theoretical experimentalist and an experimental theorist, as I once wrote in the community area of this channel. It's a fun area to write in, and I share my thoughts there. This channel is a thought experiment and like a journal to me, and I'm sharing it with the world, actually with the universe. What else can I do? The universe shares all of its knowledge with me. The least I can do is share my thoughts. So, my thoughts are pulse and then pulse, pulse, pulse. This blotch wall, this neutral area, is going to go swinging back and forth, right? Would we call that resonance? I don't know. swing this way, swing this way, swing this way, swing this way. As it's doing that, this wire, I wrap a wire, a separate wire around this magnet, right? This is just a regular neodymium magnet. It could be a series of magnets like this. It could literally be these magnets here, or it could be like a bar magnet. That's just a bar, like a neodymium bar, right? And we have to always be careful with magnets because they're very, very dangerous. And we have to always wear safety glasses. And it's good to watch safety videos on how to handle magnets if you have any plans to handle magnets for the first time, or especially if you already are working with magnets. It's always good to be extra careful and wear safety glasses, and it's good to wear gloves too. So, but I'm just sharing my thoughts here. So this magnet will be wound with a coil, right? And so as I'm putting in some power here, I don't know how much power, but I would just see how much it needs to make. I would just adjust it. I would adjust how many pulses a second. So I might start it at 1 pulse a second. So pulse, 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 pulse. I might increase that to 2 pulses each second, right? Pulse, 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 pulse. Just see what happens here on the what I'll call the output. I'm calling this the output wire, right? This coil wound around this is the one that's going to be giving us energy from the magnet when we move that blotch wall. Now, I don't even know if this is going to do anything or if it's going to work, but this is what I thought of. Okay, this is what I saw in my imagination, right? Einstein said imagination is more important than knowledge. That doesn't mean don't study, don't go to school. It doesn't mean any of that. It means study everything still. I've always been told this, always study everything. But just know that if someone ever puts a restriction on something, like says, this is the final word, or yes, there's a lot we don't know, but we know this for sure, so don't even go that direction. My teachers always said, just keep going. There's no end. And time someone puts a restriction on something, they've just put a restriction on themselves, on their own research, not on what you can do, not on what we can do, right? And that's my understanding, and that's my conditioning, and that's the way I've learned to see, and also have helped to teach myself to see, right? So, right to true education, to lead forth or to bring out something which is potentially present, right? So the education has been brought out of me, which I'm just refining my experience, and I'm in this sharing process that I'm sharing with you is helping me to do that as well. So when I looked at these pairs, and I said, well, if he's getting all this energy just by this pair of magnets, right, switching between one magnet and 2 magnets, right, just that switching back and forth, 1 magnet to 2 magnets, 1 magnet to 2 magnets, 1 magnet to 2 magnets, by having that space between the 2 sets just right, and by having just the right amount of neodymium dust, right, because that's the lowest cost material. The other materials were very expensive or rare, is from what I understand. That's the way it's been spoken of and written about. So when Don said he did this with neodymium powder, that sounds good to me. I just have to find it though. But also, will this work? It may. Regular magnet, because I see lots of magnet powder, but it might have to be thicker, right? It might take more of this because this is not as strong as a neodymium magnet. But I feel like neodymium powder should not be hard to find. It just makes sense that that's something that could be purchased. But any magnet powder should work, I'm thinking, and that's something that I'll just have to test. So, please share your results on that if you're testing this, and I'll happily share mine as I learn and make videos about what I'm doing. So, if this record's spinning, which takes milliwatts, right? It's running at, if I recall correctly, it's running at 12 volts, and I think that's on this page. That it's running at 12 volts. Well, it says here that so this motor is, the battery's a 12 volt, 7 amp hour battery, right? 7 amp battery, that means 7 amp hours, right? 7 amps for 1 hour would deplete the battery if it took 7 amps. That's the capacity, right? 12 volts powering that little motor. and this capacity of the battery is 7 amps. So 7 amps for 1 hour would deplete it, and then charging it at 7 amps for 1 hour would fill it back up, right, if we were to have to charge it again. This is the question that a lot of people want to know, is how much energy are we putting in and how much energy are we getting out? And I would say as a goal, if we want to replicate nature, nature is, so the 0-point field, this is my understanding, okay? I've read a lot of books, and I know that I'm just glimpsing the surface. I'm still a beginner, and I know that. I actually can't imagine being anything more than a beginner, but I do my best to scratch the surface, and I'm successfully scratching the surface of knowledge. So I'm very happy with that. The 0-point field, if this is what I'm going to refer to space as, right? The 0-point field, which is those all that energy, right? Energy in the 0-point field. The 0-point field powers the material universe, what we think of as matter, right? It powers that, the particles that maintain what we think of as reality. And the material universe powers the 0-point field. So it's like a symbiotic system or a self-sustaining system. It's a perpetual system. I see it that way. Meaning it just keeps going on and on and on. And nature, so I'm going to call this nature. I'm going to call it nature. Nature has given the 0-point field 10 to the 40th times more power, more energy than the material universe. Even though the material universe entirely powers the 0-point field. The 0-point field gets all of its energy from the material universe, and the material universe is entirely powered by the 0-point field. So they power one another, right? A symbiotic system. Back and forth, they power one another. Back and forth, back and forth. But yet the 0-point field has 10 to the 40th times more power, more energy than the material universe, entire material universe combined, right? Because the material universe is all pure energy as well, right? But these two energy forms sustain one another. It's beautiful. So if we use that as our model or as a reference point to be inspired by, to create by, I like that idea. So our input power here is just a little bit of input power, right? To turn this magneto restrictive metal wheel, a little bit of input, that's our input power, right? So that's like the material universe, right? The material universe putting in a little bit of energy, or taking a little bit of energy to maintain itself, right? To maintain its existence as a material universe, right? Instead of just a non-material energy, which is what the 0-point field is, right? The 0-point field is just pure energy, a pure energy that is not material, not what we don't think of it as like a book, right? This is a material, right? But the space between the space, the 99.999% empty space of every atom is what I think of as 0-point energy, right? That's the way I see it right now. I'm still refining that perception. So this wheel represents like what it takes to power the material universe. And then the output of these coils by fluxing, right? That are fluxing in the infinite energy 0-point field, right? That's our output, where it's really big output, right? 1,000 volts at 50 amps, 50,000 watts coming out of that right there. 50,000 watts. This is what Don Smith said. 50,000 watts. And how much does it take to turn this wheel? Milliwatts. So if someone wanted to calculate that, they could see how close that is to the ratio of reality, which is reality of nature, which is that the 0-point field, even though entirely powered by the material universe has 10 to the 40th times more power, more energy than the entire universe, entire material universe combined. So that sounds very similar to me in terms of a little bit of input and a lot of output. So this makes sense to me in my thoughts, and that comes from lots of reading. So one thing my teachers taught me as well was that we're spoon-fed perception, right? So, and this is everyone, teachers as well. Teachers are given, they get an education and they're taught how to teach. And something a philosopher said to me once is, and I don't know if I could say it the way he said it so eloquently, but he said, how much of your mind is actually yours? How much of your thoughts are actually your thoughts and not just someone else's thoughts that you are just perpetuating? How much, and what's the difference between the two, right? When does a thought become yours? Is it when you've used your own independent research to formulate your own opinion and your own viewpoint about what you think about something? That might be a beginning. Exciting, right? Very exciting. So I was asking myself, going back to this one here, I was asking myself, on a transformer, why is the transformer just stepping voltage up or down, but we get the same power out, right? We don't get more power out of a transformer, the watts. We don't get, the watts we put in is the watts we get out, right? So either the same or less, right? The same watts or less, right? But not more. We don't get more watts out. And I thought, well, how come that is? Why is that? Because we have a ferrous metal, right? We have a ferrous metal like we have here. It's not a magnet, right? There's no magnet in here. But when we put energy into a coil near a ferrous metal or around a ferrous metal, that metal becomes magnetic, right? It becomes magnetized. It'll have a polarity. It'll have, I guess that means it would have a north and a south. I imagine it this way, right? So what's it missing compared to this? And I'm thinking of this blotch wall moving, right? We don't have that. In my research, this blotch wall, B-L-O-C-H, comes up so much. I've never known what it is. I've never understood it until just recently, in the past like week or so approximately. I just suddenly began to see it in a new way, like actually that I want this to move, right? Because this moves when this has something to do with the way this works, right? It has something to do with it. It's right here. So right now it's blocked, right? It's being interfered with by this magneto-restrictive metal wheel. But when this turns a little more and this area goes between these two, this open area, then it's not being restricted, right? And then we have the blotch wall is right there. But when this wheel restricts, and I'm going to add to that by saying when we add the neodymium dust or the magnetic powder with an adhesive, right, so spraying some adhesive glue on a material, and then sprinkling the magnetic powder there, right? And when this goes between these two magnets, it'll flux and shift that blotch wall back to the center of each of these magnets. And then when this opens up again, when the hole opens as it turns, the blotch wall goes back here. So it's fluxing like this. It's pumping the energy. I see it this way. It's pumping the energy like this, pumping it. The blotch wall is pumping that energy and squeezing it in. Boom, 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 boom. Right? Boom, boom, boom. Squeezing the energy in. Blotch wall here and here, and then going here, and then here and here, and then here. It's fluxing, right? It's fluxing, and that fluxing, that flux, that magnetic flux is being picked up in those coils. And I don't know how much power is coming through there. I don't think I'll get anywhere near what Don Smith was getting, 50,000 watts, 1,000 volts at 50 amps. But if I can get a couple hundred watts or 25 watts or something, I will be so happy. I mean, I just want to move slowly with this. I'm not in a hurry. people see my enthusiasm and they might laugh and say, oh, you're just so excited about free energy. No one understands. No one can tell me what something means to me. They can tell me what they think they see. My enthusiasm, my excitement is because I love to learn. That's my enthusiasm. How long has this channel been going? If anything, my enthusiasm has grown exponentially. That's because the more I learn, it's the more exciting. There's so much more to be excited about. I just love it. So, but my request is for people that are researching, I think it's important that we not put one another down, not make fun of one another. We're all here together to learn, unless people are just being playful and they like it. But I think we could be positive with one another and help inspire one another. I think that's important, and I think that's exciting to me. Now, there's always going to be people trying to drag everyone down and playing like psychological games where they're nice and then mean and nice and mean and just all this confusion. But that's part of the reason the comments on the channel are not open right now, because my focus is on what I'm talking about, and it's so easy to focus when I can focus. When I can't focus, it's not easy to focus. So I'm doing my best to bring you my very focused thoughts and to share those with you, and I'm happy to be able to do that. So back here looking at the transformer, because there's no magnet here, I think that's why there's no blotch wall. I mean, the moment this thing the moment the power pulses on the input of this, right? So let's say 120 volts input. When that pulses, I mean, I'm just making numbers up, but let's say it pulses for a second. I guess there would be a polarity, but is the polarity shifting from one place to another, or is it just appearing and then disappearing and appearing and disappearing in one spot? And I think that's what's happening. Now, so that makes me think that if I put a magnet in an existing transformer, if I took a transformer, and let's just say I drilled a hole right through the middle of it and put a really powerful neodymium magnet in there, and it went through both coils, right? If there was a way to do that, I mean, I know it wouldn't be easy, or maybe it cannot be done, I don't know. But even if we made our own transformer, right, but around a magnet, see, then we're looking at this again, right? We're almost looking at that. Because if I put a magnet in here, if I drilled a hole, machined a hole through the center of this, and this side's north and this side's south, and this is the input and this is the output, now the blotch wall sits somewhere in here, right? It's somewhere in here. And then when this gets activated, that blotch wall moves. And then when it pulses off, it moves again. The blotch wall moves. The blotch wall, the center point between the two poles, right? Right? The center point. And when that shifts, when that moves, I think we have the fluxing that Don Smith was talking about. I think. I don't know. This is just a thought. This is a thought experiment. Anyway, everyone, as you can see, I'm very excited about this, and I'll keep you posted on my thoughts as they continue to develop. Okay, everyone, have a great day, and happy experimenting, safe experimenting, and I look forward to continuing to share what I think and learn. Okay, until next time, True Zero Emission, signing off. Bye, everyone.